Hello guys, welcome to Code Enzyme, and in this video we are going to discuss all the problems of starter 74 Codechef. So we have 1 2 3 4 5 6 7 8 9. So we have about 9 problems in this problem set, and till odd even binary string we have some easy problems, and after that we have pretty difficult problems. So since we have too many problems this time, I will not spend much time on these 3 problems, and after that we will discuss each one of them properly. And I will be coding in Python, so I don't know what most of you guys prefer. So if you want me to do it in C++, kindly comment down. And I'm using VS Code as my code editor, and whenever we will need to discuss something, I will use my pen tablet. Okay, so let's not waste any time, and let's see the first problem. So the problem name is mana points, and the problem code is mana pts. Okay, the problem statement is chef is playing a mobile game. In this game, chef's character is Chefario. Chef can perform special attacks. However, one special attack costs X mana points, and Chefario mana points to Chefario. Okay, if the chef if Chefario currently has Y mana points, determine the maximum number of special attacks he can perform. So there is nothing to discuss. I think we will just print the we just have to divide this by this, and next we have to print the greatest integer of that number. Okay, so I'm just going to take the input, and next I'm going to print a by b. And in Python we have this double for integer division. Okay, sorry, we have to print b by a. Okay, let's submit it. Okay, let's move on to the next problem, Facebook. And that gives us a correct answer. Okay, a post on Facebook is said to be more popular if the number of likes on the post is strictly greater than the number of likes on some other post. Okay, in case the number of likes is same, the post having more comments is more popular. Given an array A and B each having size n such that the number of likes and comments on the ith post are okay. Find out the post which is the most popular. So I think okay, so we just have to find the maximum index in the array A. And if we encounter post having two same values of the maximum values, then we also have to compare the comments. So let's let me just make a new file, and first we have to take an integer input, so int input. Okay, and next we have to take two arrays, likes and comments. I think likes was first. So in the input format we have number of likes. Okay, so I'm going to say likes is equal to map int input dot split, and in this I'm going to convert this thing to list, and I'm going to copy this line and write here comments. Okay. Okay, so we need a max value, so I'm going to say max value is equal to 0, and or okay 0, and answer index is equal to 0. Okay, next I'm going to traverse in comments for I in range n. So I takes values from 0 to n minus 1, and if likes of I is greater than my max value, then I'm going to say okay, max value is equal to likes I, right? I don't know why I'm making so many spelling mistakes here, because the mic is in front of me and it is just difficult to concentrate right now. Okay. Now if but what happens when these two are equal, right? So elif, or I will just write an if statement, likes of I equal to max value. Then I have to check that if comments of I is okay, I should also make a comments num comments variable to see how many comments we had in the last post, right? So num comments equals to comments I. So that post had this many comments. If the comment size is greater than num comments, then I have to update my answer. So answer will be equal to I, and num comments equal to comments of I. Okay. So this is how the loop will run, and in the end I have to print answer plus 1, I guess. So we had some errors. Let's see what happened. Okay. We found a 9, so the answer should be 3, right? Why am I getting so likes I, if likes of I is greater than max value, then I'm putting max value is equal to likes of I. Okay, that is correct. And num comments is equal to comments of I. If likes I equals to max value, then if the comments of I is greater than num comments, then I have to update my answer, otherwise I do not have to update my answer. So it should give us correct answer. Why is it not? So I'm going to print max value to debug my code, and it is giving wrong answer on this one. So let's make a new test case and run this. Max value comma answer. Okay, answer didn't change. Why? Because whenever if like size greater than max value, then I also have to change my answer, right? Now it should give me the correct output. Okay, I have to comment this line, and it passed. So let's submit it now, and this should pass all the test cases. Okay, so we got an AC on this one. Let's move on to the next problem, and it is odd even binary strings. So let's read the problem statement. Chef has an array A of length n such that A is equal to okay, and no constructor array B of length B I is equal to 1 if the frequency of element I is odd. Okay, and the frequency B I is equal to 0. Okay, such an array B is called parity encoding of A, simple, and that is the input format. Okay, so let me just add it, make a new file. And I have a simple observation. If n is odd and the number of ones is odd, then my answer is yes. If n is even and the number of ones is also even, then we will be always able to perform this operation, and it just worked out. Okay, and the number of ones is just the sum L, right? So let me take the input, and I can do if n and 1. So if n is even and sum L and 1, then I have to print a yes, else no, or if okay, I have to check if both are even and both are odd, right? So if both are odd, then if one is even and one is odd, then the Xor will be odd, right? So let me make a sum variable s equal to sum L. If this is even and this is odd, then it's Xor, the last Xor will be odd. If both are even or both are odd, then the Xor will be even, right? So let's just take the Xor of these two. Xor is equal to s Xor n, and then if Xor is odd, then I have to print not x, I have to take Xor, and then I have to print a no, else I have to print a yes. So I think you got my approach. Let's submit it. Okay, let's wait and see if it works. Okay, so that gives us an AC. Let's move on to the next problem. Okay, so let's move on to the next problem. Okay, so the problem name is Chef and Babla, and the problem rating is 1346. Basic math problem with implementation in mathematics. Okay, so let's read the problem statement. Chef gives an array A of length n elements to Babla. Babla's task is to find the maximum non-negative integer x such that no element in the array belongs to the range minus x to x. In other words, for this, okay, I think you have already read the problem statement, so let's just get into the coding. And if I see the constraint, there are 10 raised to 5 numbers, so our solution can be in n log n time, right? So we can do sorting and stuff. So let me just make a new file. Let's take the first integer input. Next I will take this array as input. So list map int input dot split. Okay, and now I can separate my positive and the negative numbers. So I'm going to say something like this: positive and negative. And for I in L, if I is greater than 0, then positive dot append I. Else I'm going to append it to negative. So negative dot append I. Okay, so now this array has all the positive numbers from A, and this array has all the negative numbers from the A. Now if positive is empty, then I only have negative elements, so I'm going to print negative minus 1. I'm going to multiply it by minus 1 and do a negative minus 1 from this. And if my negative is empty, then all the numbers are positive. Then so I have to do check the minimum number. So positive 0 minus 1. Else, in else case we have some numbers in both of them, so I'm going to take a minimum of the first index in the positive number and minus 1 times the last index in the negative number, so negative minus 1, and I have to subtract 1 from this, so this should work. Okay, so now let's try to debug this. Why is this happening? Okay, I didn't sort these two arrays, so we have to sort these first. Negative dot sort. Once these two are sorted, this should work, and you can see it passed all the test cases. Okay, so let's just copy this and paste it and submit it here, and it should work. Let's see. So let's move on to the next problem. It is LCM and GCD. So the problem statement is chef has two integers a and b, and chef wants to minimize the value of LCM a, x minus GCD b, x, where x is any positive integers. So in such kind of problems, we usually need to minimize the value of a, x because LCM just grows exponentially, right? And GCD, the range of GCD will be something between 1 and b, and this is usually the smaller number, so we don't need to care about this much. And how can we minimize the LCM, right? Because what is the worst case? Because if we choose any x, Then if the GCD of a and x is 1, then then LCM will just grow. We will just have to multiply a and x and it will grow. So if we want to minimize this LCM, then x must be a multiple of a. So this LCM will become something a multiple of a, right? And just this GCD will become the multiple of a time and b, right? And that will be the GCD of a and b. And if you want to minimize this LCM, then we can take that multiple to be 1, and so my answer will be something like, so if I will choose x as a only, basically. So my LCM will become a, and the GCD will become GCD of a comma b. So I hope you got the idea, and I think we don't even need to go to the VS Code here. I will just define a function as GCD. So those who don't know the Euclid GCD, you can learn about it. There are tons of YouTube videos there, and it is something like this, using recursion. So this is my GCD function, or you can also import math, and you can use math.gcd. That should work fine. I have not tried it, so I will not try it right now. Okay, so I have to take 2 integers as my input. So a comma b is equal to map int comma input dot split. Now I have to calculate the GCD. GCD a comma b, and I have to print a minus g. So let's just run it and see if it works for these test case custom input. We reckon 908. So let's now just submit it. Okay, so it gives us an AC. Now let's move on to the next problem. Okay, so I hope you were able to understand the previous problem. Let's move on to this next problem, minimal inversions. And the problem rating is 1918, so a bit difficult problem. So let's read the problem statement. Given initially chef has an array A of length n, chef performs the following operation. Okay, he selects an L and R, and okay, so if AI is equal to AI plus 1, okay, determine the maximum number of inversions chef can use to decrease the maximum number of inversions 7 degrees. Okay, so he will perform these operations from L to R. Okay, and he will set all AI to AI plus 1, and we need to find the maximum value of inversion in A minus inversion in B. Okay, so these inversion problems are pretty difficult already, and we have to maximize this. Okay, so I'm going to use we can use the contribution technique. So for example, if we have 42315, so to calculate the number of inversions, let's see how many elements are less than 4 on the right hand side of the array. So we have 1 2 3 1, so there are 3 elements, and for 2, let's also calculate it. There is only 1 element less than 2, and for 3 there is also only 1 element less than 2, 0 and 0. So currently we have 3 4 5, so 5 inversions. Currently we only have 5 inversions, and we are doing operation on 3 and 4. So basically, after summing, we are adding plus 1 to these 2 elements. So my array will become something like 4 2 3 2 6. And now if we calculate the number of inversions, for 4 we have 3 elements which are less than 4 on the right hand side. For 2 we have no element. For 3 we have only 1 element, and so our answer in this case, the number of inversions are 4. So my answer will be the difference between these two, and it is 1. No, I think I did something wrong. So the resultant will be 4 2 4 2 4 2 5 4 2 1 2 3. Oh, sorry, I did operation on something else only. We did operation on these two elements, so we will get 4 and 2, and okay. So now I have 1 2 only 2 elements less than 4, and for 2 I have 0, for 4 I have 0 elements, for 2 I have 0. So my answer will become, from 5 it will become 2, and so no, for 4 we have one more element, so this will become there is one more element on the right hand side of the array, so and the difference will become 2 in this case, and this is our final answer. But we can also observe that if we added to this whole suffix, let's also analyze this case, and this will help us reach a final conclusion. If we had added a +1 to this whole suffix, we will get something like 4 2 4 2 and 6, and you will see we will still get if you calculate, or let me just calculate it for you, we get 2 elements less than 0 and 1, and you can see we still have 5 minus 3 on this case, which is 2 as our answer. So basically it does not matter what my right hand side where we stop, because we can just add +1 to the whole suffix of the array, and that is the claim. If you observe for all the test cases, you will realize that we can simply do +1 for the whole suffix, and we have to find we have to only check for this left hand side, and if we are able to find this left hand side, we are able to minimize the number of inversions. So how can we find the inversions? Because the number of let's see the constraints here. Our n is still 10⁵, okay, and my ai varies from 1 to n. So the maximum value of ai is so the maximum value of ai is 1 to n, right? So how can we calculate the number of inversions? So we can try to find the answer using contribution technique. For example, if we have this as our answer, this as our obviously this is not the best example, but what if I claim that, okay, suppose if we want to know that, okay, if I do a +1 on this, how does this increase my how does this increase or decrease my number of inversions? So since we want to decrease this, let's say how first it will increase it. But because if we want to see what is the difference it is creating, if I'm making this 6 here, so if there had been any 6 here, suppose there was a 6 in this case, then this 6 was creating an inversion now, so I have to do a -1, right? And if there was a 7 here, right, then if I add +1 here, then it is also increasing my answer by 1 once I make it 6, right? So I have to check for all these possibilities, that how many times 7 is occurring, how many times 6 is occurring before 5, and we have to do this in least possible time. And the best way to do this is we can create a frequency array, right? So we can maintain a frequency array, and suppose we will do this, we will subtract the number of times 5 is occurring till now, and number of times 6 is occurring before it, right? Number of 5 is occurring till this point, right, before 5 not included, and once I have changed it to 6, then I have to consider this whole thing, And now I will check how many times 6 so basically I have to first subtract the number of times 5 is occurring before, and after that I have to multiply it with the number of times 6 is occurring. Then I have to check the number of times 7 is occurring before that. Sorry. Then I have to check the number of times. Okay, if there was a 4 here. What I mean to say is, suppose if there was a 4 here, right? Because suppose if there was a 6 here, okay? So I want to count the number of times 5 was occurring till now into number of times 6 was occurring, because that was creating an inversion before I have converted this 5 to 6, right? And I also want the number of times I also want to know the number of times 4 was occurring, because I also want to know that okay, this 6 and 5 are creating an inversion, but there are also possibilities that now, but I also want to know the suppose if there was a 4 here, then I also have to check that okay, since this was also creating an inversion, it will not create an inversion anymore, right? So I also have to count the number of suffixes in the after this. So I have to count, say okay, number of 4s it was occurring into the number of 5 in the prefixes, and I have to subtract this. And after I have converted this whole thing to +1 I have to check for this again, and I have to add the same thing after changing it, and I have to keep doing this from in this direction, and I will take the maximum, right? Maximum answer comma whatever that count is. And I think it is pretty difficult to understand in one go. You can just rewatch this again and again and try to write this on your own, and you should be able to understand this. So let's just see how we can code this. So let me make a new file. Okay, and I'm going to take the n input, and now my list map int input dot split. Now I also and now since I am at this point at this last index, I want to know the number of times every element is occurring. So I am going to make a frequency array which is initially 0 for n+1 elements to avoid the 0 indexing. And I also want to have a suffix array, so let me name it prefix array and suffix array, and this will also be 0 for n+1 elements. And for I in L, I have to do prefix of I plus equals to 1. And why is this till n+1? Because we have if I check the constraints, we have 1 to n. Okay, AI ranges from 1 to n, and we can use a map also, I think, but using this method is a bit faster, because in map we have it has to find the index, and it will cost a bit of time. Okay, let's see what we can do now. So now we have calculated the prefix of the array, and now we want to traverse from the right hand side and go to the left side. So let my final answer be 0, and let my count, the inversion count, be initially be 0. So I'm going to loop for I in range n-1 to 1, and obviously this one will not be included, so I have to do a 0, actually -1. I'm going to do a -1. Okay, now if I am here, first I have to decrease the current minus equal to, so decrease, because suppose if you want to know the result for these two, we want then I have to, using inclusion and exclusion principle, we know that A union B is A plus B minus A intersection B, right? So something like that, if you can imagine it. And I'm sorry for that noise. I'm currently in a hostel. Okay, so so something like that. First we subtracted, then we added, then we again subtracted, then we again added, something like that. Okay, so just bear with me. So first I have to do even in this drawing, first I have to check the number of L of I. It currently it is in the prefix of the array, times I have to check the number of 6 L of I plus 1 in the suffix of the array. So suffix of L of I plus 1, right? And in this I have to add the number of times L of I minus 1 occurs in the prefix times the in the suffix L of I occurs. Okay, next I have to increase next I'm going to do is I'm going to decrease, because when I traverse from this to this index, I have to remove this 5 from the prefix and add it to my suffix, right? So I'm going to say L of I prefix minus equal to 1 and suffix L of I plus equals to 1, and I'm going to copy this statement again. Just the difference will be that I have to add this thing now. So I have made the changes. I have added my plus 1 to the whole suffix array, and now I'm going to maximize my answer. So, and in the end I can just print my answer. Okay, why is this happening? I can just increase this by 1 and it should work out, right? And I'm getting a 0 0 0. I think it is because I have done this and I'm still getting a 0. Okay, why is this happening? I tried to maximize my array. Let's just do a quick print count here. My count is always negative. Okay, because I didn't do a plus here. So okay, and I'm getting a 2 1 and 3. Okay, now why is this happening? Minus equal to 1 plus equal to 1, this is correct. I think I did this mistake. So count minus equal to prefix L of I times suffix L of I plus 1, that is correct. Prefix L of I minus 1 times suffix L of I, that is also correct. Prefix L of I minus equal to suffix L of I plus equals to 1, count plus equal to prefix, that is just a copy and maximum. Okay, this should be prefix A of I times, because number of times 5 occurs times the number of times 4 occurs, that is going to be also going to be disturbed, and number of times 5 occurs times the number of, and the number of times 6 occurs times the number of 5 occurs, that is also going to be disturbed, right? And I have to copy this again and I have to paste it here with a plus sign, and okay, it passed the test case. Okay, so that was a little bit of mistake on my side. Let's just copy this and paste it and see if it works. So let's paste it and run it and see what happens. So that gave us an AC. Let's move on to the next problem. So let's move on to the next problem, distinct values. And the difficulty rating is 2236, so quite a very difficult problem. It is definitely a division 1 problem. And so the beauty value of an array is defined as the difference between the largest and the second largest element of the array. Note that the largest and the second largest element can have the same value in case of duplicates. Okay, and the beauty value of 2531 is equal to 5, because largest is 5 and second largest is 3. Okay, and the beauty value of 767 is 0. So okay, so Hmm. So you need to know about how we can calculate the beauty values. I mean the next largest element, right? So if I just take this example, let's use this 69421. Okay. So if we have this array, 6, 9, 4, 2, and 1, and I want to calculate so basically we want to know how many distinct, we want to know the number of distinct beauty values. So we want to know how many ways we can have distinct pair of a largest and a second largest, right? And we can obviously do it in O of n square, I think, but the constraint does not allow us, obviously. So we need to somehow minimize it, and we can do it by, I mean, okay, so if the question is pretty straightforward, it asks us to find the next largest element, right? And it is easy to calculate next largest element in O of n square, and but there is also an implementation using stack. Basically this is a stack application, and if I just I will just show you on Geeks for Geeks. So if I just Google what was that, next largest element or next greatest element, and there is a Geeks for Geeks link, and you can read about this article. And the naive approach uses a O of n square, and basically we can find greatest element using stack. So and you can just read about this. Okay, so if we use stack, we are able to do this in big O of n. So in big O of n, what I will achieve is what is the next element greater than 6 in this whole, just greater than 6 next to 6, so it is 9, right? And what is the next element greater than 9 in this whole array? It is -1, because -1, let it be -1, it can be any value, default value something, because there is no element greater than 9 or equal to 9, right? And in 4 I have to check how many next element greater than 4. No, there is none, there is none, and there is none, right? And similarly in big O of n, I will calculate the previous greatest element. Just like next greatest element, I can also use this concept and calculate the previous greatest element. So if I calculate the previous greatest element for 6, there is none. Previous greatest element for 9, there is none. And for this we have 9, we have 4, and we have 2, right? So obviously we can't use -1s. So basically we have one pair will be 6, 9, and since this 9 has both -1, we will not use this. One pair can be 5, 4, 9. One pair can be 4, 2, and one pair can be 2, 1. And we can add all these values in a set, so that will help us remove all the duplicates. So 6, 9 will give us a 3. This will give us a 5. This will give us 2, and this will give us, so there are four distinct beauty values, right? So this is how we are going to implement it, and so let's not waste any time, and I will try to code this. So let me make a file. I will take okay, I have to first take an integer input, so n is equal to int input, and next I have to take the array input, so L is equal to list map int input dot split. Okay, next I have to check for the number of beautiful values. So first I have to check for the next maximum and the previous maximum. So I will make a previous, which is initially -1 times n, and I also have to find the next maximum. So next is equal to, initially it is -1 times n. Okay, Now I have to calculate it using this Geeks for Geeks article, right? Okay, I closed it. So you can just try to read and understand that. It will hardly take you more than 10 minutes, and you can just come back to this video after you have learned that concept, right? So I will code that now. So first I will try to find the next greatest element. So I have to make a stack, okay, and for I in range n, so I have to calculate the next greatest element for every element in the array. So I'm going to say while my stack is not empty, I have to do if stack dot top, right? So if the top of my stack, I'm storing the indexes in the stack. So if the top of stack is less than the element, then I have to pop it. So stack dot pop, else I have to break out of this loop, and this will give me my greatest element. So if stack, then I have to do if stack, then I have to do next of I is equal to stack minus 1. So this will give me my next greatest element. And similarly I can and at the end I have to append this to the end of the stack, and I can use this whole thing to calculate my what can I say, actually this should be in a reverse. This is actually calculating my previous greatest element. It should be a reversed range, otherwise it will not give me the correct output. And here I have to make a previous. So let's just print next and previous for once, just to see if it is working. So I had this test case, and let's see. So we are getting a 1 minus 1. Okay, so the first index, that was 9. So 1 minus 1, okay, that is correct. And minus 1 minus 1, 1 2 3, minus 1 minus 1, 1 2 3. So this is giving the correct output. Now now we can code further. So we are done with, we have calculated the next and previous greatest element, and now we will try to minimize the answer. So I can make a set as my answer, right? So let me make a set, and in this set I'm going to append the differences. So wherever I will see that okay, the difference is not minus 1, then I'm going to append it to my set. So for I in range n, and now I'm going to check if the previous I is not equal to minus 1, because if it is minus 1 I don't have to consider it. So if it is minus 1, if it is not equal to minus 1, then I'm going to add it to my set. So set dot add, and what I'm going to add, I'm going to add the difference of these two. So since this is second largest, then previous should be the largest, right? So I have to check for a of previous I minus, sorry, not array, it is I've stored it as a length, the L of I. And similarly I also have to check for the next one. So if my next is not equal to minus 1, then I have to do next here, right? And after this I have to print the length of answer, length of this set. That should give me the correct output, right? So it passed, and now let's just submit this and see if it works. So submission is queued, and we have to wait for a couple of minutes. Okay, so that gives us an AC. Let's move on to the next problem. Okay guys, the video is pretty lengthy, so I don't want to waste much time in coding them, so coding any more problems, because these two problems are quite lengthy ones. And I've decided I will just show you give you some hints about how you can solve these two problems, and not I will not write the full code because it will waste a lot of time and it will just make the video lengthier, right? And I don't want to do that because uh, I've seen that the longer the video, the less I get the number of views. So if you want the full solution with code, you can just comment down this video, and I will make a separate video on these two problems if you want that. Okay, so let's see what we can do in this candies problem. We have chef has infinite okay number of candies, and the ayat customer will buy exactly one p candies. Okay, and we need to find the maximum amount of bonus you can get, and we have n comma, so we can't go in n square time complexity. And okay, so basically there is no way we can traverse from for all over n, right? We have to find some way to stop somewhere and decrease the time complexity, because it is pretty easy to write brute force in O of n square. And how can we decrease it? So let's understand with a problem statement with this 31415 sample test case. So we have 3, 1, 4, 1 and 5, right? And the CJ is given as 1, 4, 5, 5, 5, 5, 8 and 99. Okay, and so the corresponding my prices will be 1, 2, 3, 4, 5 and 6, right? So obviously I'm not going to code right now, so I will just tell you what you have to do in this one, because so the logic was something like if you can fix the price. Suppose we can't obviously decide which will be the minimum, so we have to do it for every price, right? And so we have to traverse for all these prices 1 to 6. And if we see the constraint, I know that AI is less than m, so I don't have to traverse for every so if AI is less than m, then we can say that if I have fixed my price, suppose if I have fixed my price for 3, and I know that there are 1, 2, 3, 4, 5 elements, so obviously my AI will be less than 5, so I don't have to check for less than 5, less than 3, 5 by 3. I mean, suppose if I fix my price and I want to know how many people will buy exactly 1 candy, 2 candy, till 5 divided by 3 number of candies. Okay, so and whichever will give me the maximum, that will, in this direction you have to think of it about it, right? So that is, and it will make use of binary search and some range queries, I think. So something I don't know, I will just leave it here, and if you really want me to make a solution on this one, I will make it in another video. Okay, let's see the next okay, so let's see the next problem. Maximum Xor sum. I don't know why we have, okay, we have Xor. So Xor problems are already pretty difficult, and we have and the difficulty rating is 2497. So a pretty good difficult problem, and we are given two arrays A and B of non-negative integers for x, and an array x of length n is good if this holds true, so the prefix of xi should be equal to a of I. And the and if I see, this is the suffix, right? So the suffix of xn should be b of I. So, and it is given that where it is guaranteed that such a such a array x will always exist, and we have to maximize our solution. We have to maximize this XOR thing, right? So for example, if we have something like uh, we want to maximize the number of bits, and we are using let me see the constraints for first. We are using 2 raised to power 30, so we will have maximum of 30 bits. So we have to we can whenever we have something based on bitwise operations, we should think about the uh, elements of the array in bits, not the integers. So for sorry about that. So for every element in the array, we can think of it something like okay, for ith bit I will first calculate the number. So if my array, if this holds true, my array a must be something like 0 0 0. First it will have some zeros, then it will continue to have some ones, right? Because if now it has 0, then I can't make an array x which has OR of all these elements, bitwise OR of all these elements as 0, because it has a 1 in between, right? So if such an array exists, then my array A should be something like this. This is if this is the case, then I will have no possible value of the array. So let's see another and so this is something this will be my A, and correspondingly my x will be something like 0. It will have 0 0 0, and once I encounter 1, I have to put a 1 here for the first one, and this bit can be anything, because if I take the bitwise OR of all these elements, then it will be 1 for sure, right? So I am not sure what bits will come here, but I am sure that this bit will be 1. Okay, and for b to exist, if my b is something for b, okay, let me write it in the above line. And if we have a b here, then my b should also be something like this only. We should have 1 1 1 1, and then we should have some zeros at the end. Now I have to now my x will change, because now I have to put a 1 here, because in the x we have prefix, I mean suffix, we have to take ands, right? So if I don't put a 1, basically the value of and of all these numbers is 1, right? And now in this okay, let me decrease some ones. Suppose there was a 0 here, then I should put a 0 here, right? And this bit can be anything, because the bitwise OR is obviously 0. I hope you are able to understand this. And so basically we are not sure what this bit will be, but I am pretty sure that these other bits are fixed. Okay, and since we have to take XOR, XOR is all XOR of all these, and we want all the XOR of all these to be 1. So when will it be 1? If the number of ones in this x is odd, then our XOR is 1, and if it is even, then I have to check if I can make the number of ones as odd, right? And if I can make it, I will do it. So that is how we are going to implement this. So I hope you were able to understand this one, my approach. And so this is it. I am ending this video now. If you found it helpful, kindly like this video, subscribe to my channel. I will see you guys in next time, where we will discuss more problems like this. So thanks guys, and I really want to thank those who commented down this video and really keep my motivation up. So thank you. Happy learning.